Everyone. Last video we dealt with the first example of series, and in this video we're going to take a look at the second and final example of series that I have for you. And here it is. So begin with the series sum from k equals 0 to infinity of -1 to the k, and the sum from k equals 0 to infinity of 2 to the k. Illustrate the two forms of divergence, bounded and unbounded, present in these two series. So pause the video, work through your own solution, and then I'll reveal my solution after that. So for the first series, we have S sub n equals 1 minus 1 plus 1 minus 1 plus -1 to the n. So we have here that the partial sum S sub n equals 1 if n is even and 0 if n is odd. We can verify that by looking at n equals 0. So we get S sub n equals -1 to 0 equals 1. As we have here, and then if n is odd, n equals 1, let's say. So S sub 1 equals -1 to the 0 plus -1 to the 1, which is just 1 minus 1, which is 0. So the sequence of partial sums reduces to 1, 0, 1, 0. Since the sequence diverges, the series diverges. So this is an example of bounded divergence. And we say this is bounded because this sequence of partial sums reduces to this sort of binary sequence where it's between 1, 0, 1, 0, just bouncing back and forth between 0 and 1. So this sequence is this sequence diverges and it's bounded by those two values, the 0 and 1. So for the second series, we have that the partial sum equals 1 plus 2 squared plus 2 to the n. So since the partial sum is greater than 2 to the n, so we're going to take a look here. We can confirm that this partial sum is greater than 2 to the n. So this partial sum equals all of this, whereas 2 to the n is just this. So since 2 to the n is included in the partial sum, and the partial sum includes all these other elements, the partial sum is greater than 2 to the n. The sum tends to infinity and the series diverges. So let's take a look at the limit of 2 to the n as n approaches infinity, which is infinity. This is just an exponential. It's always going to increase to infinity. So since S sub n is greater than 2 to the n, and we know that 2 to the n tends to infinity, then S sub n also must tend to infinity. And sort of this tells us that since the partial sum tends to infinity, the series diverges. So this is an example of unbounded divergence because we have the series diverging to an extreme like infinity here.